All right, everyone. So, welcome to Calculus 1. My name is Jonathan Earl, and I will be instructing you for the next 6 weeks under what I guess we can call kind of unique circumstances. Okay, so for this first video, I'm mostly just going to go and give an overview of the course, so go through the syllabus, schedule, and then give an introductory presentation. Okay, so the important things, my email is found here, jearl5@uyo.edu. Let's see, our course will run from July 6 to August 14. My office, for whatever it's worth, is in Ross Hall 307, but it's very doubtful that I'll be there at any point. So as a result, for office hours, what I will probably do is try and do regularly, hopefully, scheduled Zoom calls on Monday or Tuesday, and if that doesn't work, you can always just email me and we can set up a time. We have a textbook, but it is optional, so the textbook that I'll more or less be working from is Calculus Early Transcendentals by Briggs, Cochrane, and Gillette. They released a third edition last year, but if you have a prior edition, that's not a big deal. And if you don't get either edition, it'll be okay. The textbooks do come with access to the My Math Lab, which would be useful if you're planning on doing Calc 2 or Calc 3 in the fall. We won't be using any of the online product, but that would also give you an e-textbook as well. If you're a little bit rusty on algebra, I also have a reference for you that you could look into. For this, especially for the first few topics, algebra skills will be very, very important, and that's mostly what today's presentation will cover, is just an algebra review. Everything of relevance will be in the WIO courses page. Particularly, I will post links to all of the videos under a WIO courses announcement, and then any homeworks and such will go in there. Okay, so the way the course will be structured for grading, we have 2 tests, a final, there will be some written homework, and what we'll broadly refer to in-class work. The in-class work is more going to be worksheets that will be done over mostly every topic that we do, and I'm going to grade these for completeness instead of accuracy. So what that means is if you put in a good faith effort into the problem, you get full marks. If you leave something blank or um, you don't really do the problem, not full marks. Okay, so we have the two exams during the course, and then a final. There are various ways that we could try and conduct these. I think the simplest way of doing these is I'm going to just trust all of you to do a closed book test. So the way that I plan on doing all of these exams will be that I'll put a test file up in the WIO courses, and you will have 2 hours to do it, and I'll trust everyone to do it within 2 hours and not use any external resources. So I think that's the easiest way of doing all of these for both me and you, so it seems like a reasonable way of doing it. Yeah, so office hours, so as I said, I probably won't be in Laramie at any point, and I might not even be in the United States at any point between July or August, so the only way to really get a hold of me will be Zoom calls or emails. If you are in Laramie, as far as I'm aware, the Center for Assistance in Math and Statistics is still going to be going on, so the basement of Ross Hall. I'm not exactly sure if that's going on, but last I knew it was. Okay, and then I think that covers roughly everything that we need to say about the syllabus. If I need to make any changes to it, um, I will let you know in a video and or update the file in the WoW courses. So again, so the things here are more or less guidelines. If I need to change them, I will. Okay, so the schedule that we're going to more or less adhere to. So the first video today, I'm going to do an algebra review, and then to give you an opportunity to see kind of some of the skills that you'll need. Um, the algebra stuff will be very important, particularly through this first week where we talk about limits. Um, if your algebra skills are very rusty, you want to go and brush up on those, because if your algebra skills are very poor, it makes it very hard to work with limits. Broadly, what we can kind of see is that we can break up any break up the course into kind of 3 2-week periods. So we have a 2-week block, and then we have a test. We have another 3-week block and a test, and then a final third week block, and our final. For days before the test, so the 16th, 30th, and then the 2 days before the final, I'll just for those, I'll probably have a Zoom call for a couple of hours that I'll leave open, and if anyone has any questions in preparation for the test, you can just drop in and ask. Let's see, so on the 15th, what I'm planning on doing is an introduction into computer algebra software. So I'll go and post a link to Sage, which is a computer algebra package, which has the nice benefit of being completely open source and free, which you can download, and then I'll give kind of a brief presentation on how you can do some work with computer algebra, which is really useful for this and also any other math classes that you take. Okay, so with those things out of the way, I think we can get into just a very brief kind of algebra review. So just review some of the rules for working with various mathematical objects. Okay, so suppose that we have a couple of integers, n and m. M is non-zero. If we have x raised to the n divided by m, that is the same thing as taking the mth root of x to the n. If we take x to the minus a, that is the same thing as writing it as 1 over x to the a. That's not saying minus x raised to the a. So accordingly, x to the minus n over m would be 1 over the mth root of x to the n. If we have the quantity x plus y squared, we would have to expand out that expression, and we would then collect like terms. We would get x squared plus 2xy plus y squared, and I guess the common mistake with this one is to just write it as the square of x plus the square of y, which is not correct in general. Let's see, so if we have x plus y all divided by x, a common mistake with this one is to say that there is an x in the numerator, there's an x in the denominator. We can just cancel those away, and we're just left with y. This is also not correct, but I've seen this mistake get made many times, so it's profitable to mention it and just say, let's avoid it. So if you're given x plus y all divided by x, you can split up this expression into x over x plus y over y, or 1 plus y over x. And that's not equal to y in general. Now, if you have a divided by b plus c, you cannot just split that up as a divided by b plus a divided by c. Those are two very different things. So one rule of thumb that I would advise is, if you're ever doing some kind of arithmetic operation and you're wondering whether what you've done is correct, just go and put in a couple of numbers to go and see if you've done the correct thing. So for example, with this second one, if you wanted to say that a over b plus c was a over b plus a over c, just go and put in something like a equals 1, b equals 2, c equals 3, see if your expression works. If what you find is that the left and the right-hand sides are not equal, that tells you that you're doing an arithmetic operation that's not valid. Okay, there's there's this term called the conjugate, which we're going to make fairly extensive use of when we're working with limits. So if you have the quantity x plus y, the conjugate of x plus y is x minus y. And the reason why this is useful is that if you have the expression x squared minus y squared, that factors into a different, or a sum and a difference. So x plus y times x minus y. The mnemonic to remember it is that a difference of squares factors into a sum and a difference. And what we'll do a lot when we're working working with limits is we'll multiply by 1. And what I mean by that is if I have x plus y, I can rewrite x plus y as x plus y times x minus y divided by x minus y. Because x minus y divided by x minus y is just 1, written cleverly. And when we're doing particularly limits, we would need to leave our expression unchanged, and multiplying by 1 is a way of leaving your expression unchanged, but maybe rewriting things in a more convenient fashion. So we could rewrite x plus y as x squared minus y squared, all divided by x minus y. There's also the idea of function composition. So this is something else that we'll take advantage of. We'll mention it a little bit when talking about limits, but more after we move on from limits. So suppose we have the function f is equal to the quantity x squared plus 1, all raised to the 2/3 power. If we go and we take g to be the function x to the 2/3 power, and h to be the function x squared plus 1, we could rewrite the function f as g of h of x. And all that's saying is, for g of h of x, everywhere where you see an x in g of x, replace that x by h of x, which in this case is x squared plus 1, and if you did that, you would have x squared plus 1, all raised to the 2/3 power, which is exactly f. Okay, some terminology about polynomials. So if we have um, a sum of just positive powers of x, so we have an an x to the n where n is some positive integer, and then we proceed all the way down to an a1 times x to the 1 plus a0, which is just a constant. We say that the an x to the n is the leading term, and the an is the leading coefficient. For any polynomial, if you give me some number r so that your polynomial evaluated at r is 0, we say that r is a root of the polynomial. And if you give me two polynomials, p and q, so that q is not 0, if we take the function f equal to p divided by q, we call that a rational function. Okay, so this gives us a short introduction to some of the things that we're going to take advantage of in the coming days, particularly when we talk about limits. And this also gives you an opportunity to just make sure that your algebra skills are up to par. I'll have a worksheet that'll just be an algebra review in WIO courses, so please fill that out, turn it in to me by tomorrow. Okay, and then I will see you in the next video.